Yeah. So all right. So how you guys doing today? Perfect. All right. So I'll just move on to the chapter 19. So here's a one addition. You can also talk about. This is a hydride. Oh, sorry. Okay. This is a hydride addition here. Okay. So in case we can treat the aldehyde alcohol with the sodium borohydride. So we have maybe this one. Have here, and we're gonna treat with the sodium borohydride and maybe ethanol, and a bit of a acidic condition. So if you have this one over here, what happens to this one is this one will actually going to make the hydride addition. Okay. So we'll go to there. So that makes the one pair of electron goes to the electron. So after that, they're going to have this one, and then this will going to be negatively charged. It's now have additional. So once previously just 2, now it's 3. Okay, and then they just grab one of the protons from hydronium cation, and then will become hydroxy group. Okay, so will become primary alcohol. And then in case you have the R group here, so it will make you ketone, not aldehyde. You're going to do the same thing. So we'll do this. The hydride will go to there, there. Okay. And then you're going to have the secondary alcohol here. So only difference is the either you're going to have a primary or secondary from the aldehyde and the ketone when you have addition of the hydride from the borohydride. So this is kind of way you can get some alcohol there. So if you can try to do this one. Okay. We can try this one real quick and then we'll move on. About 1 minute. Okay, so we're gonna do over here. Okay, so you can do so, but this is implied, so okay. And yeah, okay. All right, so let's move on. Can I move on? Yes. Good. All right. So the next one is what we call the Grignard reactions. Okay. So we're gonna treat it the aldehyde or the ketone with this form. So we're gonna have a R magnesium X. So this is any halogen you can try. So I'm gonna change this one to maybe bromine here. Maybe you can change this R group to maybe methyl group over here. So what happens to this one is when they break apart in here, they're giving us this R group as negative and positive on this magnesium part. So they separate in this way. So this will have, because this is relatively speaking higher in connectivity because this is metal. And so we have a 2 lone pair on this oxygen here. We'll try to get this one because it's positive. And this will be gone like this. Okay. So this will become positive here. Okay. And then this R group with the negative charge go to there. Okay. So then this will become this is a positive charge now. It's gone. Okay. So there's 2 lone pair, and this will be gone. Okay. And then later we're gonna pick up the 1 proton from the water. So they become like this, and then this will be positive charge. So they're going to grab this one. So in this way, you can have like, did I say? Was it here already? So this one. So you have a tertiary alcohol over here. If you start with the ketone, you're actually adding that R group here to where you had a very electron poor carbon with the carbonyl groups. But the later this oxygen will catch the hydrogen, so this will be tertiary alcohol here. Okay. So if it was aldehyde, maybe this one. Okay. It could have been just what? Second. Because you had the same thing, so you have addition of the R groups, so make it more higher degree of the alcohol once the oxygen catches the proton there. But the only difference from the aldehyde and ketone, you treating with the Grignard reactions, it is going to be a bit higher degree of the alcohol than what we did with the hydrazine. So hydrazine just adding the hydrogen, but in here in the Grignard you're actually adding the R group. So it will be 2 secondary alcohol from the aldehyde in this one, and tertiary from the with the ketone with this Grignard reaction. Okay, so because the difference is this one. Makes sense, right? Okay, so you can maybe try. Maybe yeah. Can you guys try this one? This one. We'll move on. About 1 or 2 minutes. Okay. All right. So yeah, we're gonna do here. So you just had this one there. And so the trick is you just add what? This one, which is coming from here. And then you just try to remove the double bond. So that's the trick. Okay. Maybe you can try just one more and move on. This time I'll give you aldehyde. 1 or 2 minutes. We'll do this together. Okay, so yeah, let's try to do this one. So basically, you just add method group here, this one. So the secondary alcohol. This is hydrogen. All right, so let's move on. Can I move on? Okay. All right, so the next one is what we're gonna discuss is the imine and enamine formation. Okay, so imine simply means you have carbons with 2R. But also double bond with the nitrogen, and it has 1 R group. Okay. So this is imine. Enamine means you have a carbon that is the single bond to the nitrogen with 2 R. It has the double bond between the neighboring carbon there. So we call this the enamine. This is imine. We call this enamine because this is the ENE. Double bond, and you have amine groups here. So we ENE plus amine, so we call this enamine. Okay. So imine just had a double instead of oxygen, but nitrogen with the 1 R, and we call imine over there. Okay. So let's try to do a practical problem with this one. Let me show you the actual mechanism first. So we can try. Okay. So we can try to have the carbonic group here. Either you have a ketone or aldehyde. You can have a primary amine comes in. Okay, and then what you can do is you can try to get the protons over here. So if you have a primary amine here, there is a lone pair on this nitrogen. We'll go to the electron fluorocarbon over there. So that makes the push on the pair of electron in the double bond in the carbonic groups goes to oxygen over here, and this will become negatively charged. Okay. So what happens to that one here? Okay, over here, and then this one will be taken by this one. Okay. So this is now plus charge, but this goes to there. It's become all over here. Okay. And then whenever it treated with this Maxitic conditions, it grabs the, once again, proton plus water. So they grab the proton over here, so become water. But it will be positively charged over here. So because this is a positive charge, it wants to grab this one over here, and then one pair of electron goes there. So this will be plus again, but picked up by water. so they can be neutral again when it goes to the proton. Okay? So then eventually you're going to have a carbon with the nitrogen had a double bond, but only leaving one R over there. So you have leaving. Okay. So one thing you can do is maybe you have this one over here, right? You can treat it with this the primary amine. Maybe you can have this one. This is a hydroxyl. This is a hydroxyamine. And then what you really need to do is if you look at this one, this is carbon to the oxygen here, right? And then just remove the oxygen and switch to the N. And then you have so these two, it will be gone. They're gone. And then just leave that whatever the left on the groups over here. So that's it. So the trick is whatever the group on this the primary amine, okay, either in hydroxy group or anything, try to remove the oxygen, replace it to nitrogen, and just remove the two hydrogen there. Okay? And then you have the amine compounds. This is a trick. Okay, maybe can you guys try this one real quick? You can try this one. There's also primary amine. Okay, maybe we can try this one. Methylamine. Okay, maybe 1 or 2 minutes. Okay. Okay, about 1 minute. So yeah, you can do the little bit of trick. That will be just. Okay, so what you can do is once again switch this one to nitrogen and keep this R group. Just these two will be gone, and we have N. You forget, right? Okay, let's move on. All right, so how about we have so how about we have a secondary amine? So it means you have the NHR2. Okay. So in this case, will be pretty much similar. Okay. So that goes to there. So this will be gone too. It's a negative charge, and that grabs the hydrogen over here. Okay. So and they're attached to that one, but this hydrogen picked up by this negative oxygen atom here, so it'll be gone, and with a 2R. So this will become hydroxy group. Okay. Yeah. Yeah. So did you see? Actually, do I need to slow? Okay. So this one goes to there, right? So then this will be positively charged because it's donated electron to the carbon here, and this oxygen will be negative because the double bond will be gone. Will be on the top of the lone pair will be on the top of the oxygen, so it'll be 3. Okay, so it'll be negative, and then this positive one equals this one, so this will be gone because it will be donated to here. This will be neutral again, and this will be neutral again, but with the hydrogen. Okay, and then it's pretty much the same, right? So we have another one. Grab this one here. So this one will come water, but with a positive charge now, because now it has only one lone pair there. With the 3 bonding, so with 5 instead of 6. So this one wants to leave. To do that, you also need to have the push. So this will lone pair, but this nitrogen will be onto there, so they can leave. So if that happens, this is what. So once again, nitrogen will be what? Positive charge again, right? But here they don't have a no more hydrogen to be neutralized again, like it did for the primer, because primer had 2 but only 1. It's gone. So they actually use one of the hydrogen on the neighboring carbon instead. So this is taken by water. Then this goes to there. So to have electron between carbon and hydrogen goes to here. And then this one will goes to nitrogen, so it can be neutralized. But no more double bond, but it's a single bond. So they mean you had a double bond and it was N, but here you had another one, this one, so actually double bond formed between these 2 carbons, not here. But in that way it can be neutral again. So we have double bond and amine groups together. Does it make sense? Okay. So let's try the problem. We can do it together. You can try. Can you try maybe this one? Yeah, this one real quick. About 1 or 2 minutes, but don't worry about it. We'll do this together. Okay. About 30 seconds. Okay, so yeah, so if you look at this one over here, just try to use implied hydrogen on the neighboring carbon. It doesn't matter which one. And then only thing you have to do, this is trick, you just change it to the single bond and remove that, so replace to the nitrogen here, and then this will be there. Let's do one more. So we have and then we can change this one too. And then we'll move. Okay, but yeah, 1 minute. We'll just okay, 30 seconds. All right, so so we're gonna do is so we're gonna switch this one to the nitrogen, but with the single bond. and we keep these two R groups, which is methyl groups here, and then make sure you also put double bond. So you have a enamine. Makes sense, right? So yeah, once again, so try to, if it's a secondary amine, change this one to the single bond with the nitrogen, keeping all R, and just make sure you have a double bond right next to it, so we can call this enamine. So E and E and amine groups are enamine. All right, so can I move on, or are you gonna do one more? I'll move on. Perfect. All right, so if that is the case, we can now move on to the next reaction. We call this the Wolff Kirchner reaction. So what we're gonna do is, if you have some compounds with the some carboxylic group over here, you can treat it with the this one. This is what we call high urazine. So if you do this one, I'll show you the trick first. They can reduce the carbonate groups, so it'll be just nothing there. It will become. So you're actually adding 2 hydrogen over here. Some basic. Okay, so if you think about this one, I'll show you the mechanism actually quite short here. So do you guys remember what we just did for imine, right? Primary amine. So we're gonna do the similar work here. So if you try to treat this one with the hydrogen here, which is similar to what? You have a this is like R group, 2 hydrogen. So it's like this type of reaction, right? We just did. So we're gonna do the same. So we're gonna do what? We're gonna switch this one to this one and this. Okay. So initially you have this one over here. Do you see? So this is like a primary amine. So we replace the oxygen with the nitrogen, the R group here, and then now it's easy. So you have potassium hydroxide, meaning you have a lot of OH minus. So they grab this one, and then this will be gone. But this pair of electron goes to here. That makes the push. So this is a carbanion here, negative charge. They grab the hydrogen from the water. Okay, and then if they do it one more time, they can grab this one as well. There will be triple bond, and this will be gone with the grabbing another hydrogen from water. So there'll be 2 hydrogen here. And these 2 nitrogen elements will leave with the, and also by doing this twice, you're gonna have a water as well. So I just didn't show you how they work. This is a part of the imine part. But once you do it, they capture this hydrogen on this nitrogen twice. It makes an eventual triple bond with the breaking this bond and 2 hydrogen there. So this. Okay, so this is, I think it's pretty, yeah. So let's try to do problem. Let's do, oh yeah, let's do this one. It's aldehyde. Can you guys have this one? Okay, about 1 or 2 minutes. I will. Okay, so yeah, so it's pretty much the same, right? So we're gonna replace this one to N, and then OH minus will pick up one by one. So either double bond, grab this and the hydrogen, so the hydrogen, they grab one more time, so it'll be gone, and then triple bonds break, one more electron goes there, grab another hydrogen here. So this will become what? Reduced. So these two are added there. Removing carbonyl groups. Okay. So this is just the. So on the exam will be just this one because you don't have to show the hydrogen. So. Okay. Yeah. You want to do one more? Can I move on? One more? Okay. Let's do one more. Okay, how about we can try this one. And then we'll move. Okay, so yeah, what I'm gonna do is pretty much the same here, and OH minus, grab this one, grab another one, so we gone, triple one gone. So this will become like this, right? So this, you can apply the hydrogen, so it's so basically, you can just remove the carbonyl group there. There will be what you can do with this, the Wolff-Kirshner reaction. Makes sense, right? I think we can move on. Okay, perfect. All right, let's move on. Okay, so the next one is what we call acetal formation. So acetal formation means you have a carbon with the 2R, okay, it could be either hydrogen or ketone, doesn't matter. But it has two, like an ether group, like this. I would just give you like here, this. But if you have those two groups on the same carbon, we call it acetal compound. So we're gonna do this with the carboxylic group with the alcohol here, and very acidic condition. So, for example, if we have, okay, let's try to do cyclohexanol. and all. So if you have this ketone over here, you can try it with some alcohol. Okay, so maybe but two. So all ROH is any alcohol, but I can try methyl groups of methanol. So be 2-methanol and very acidic condition. So we're gonna put hydrochloric acid. Okay. So what it happens to here is they're going to have this oxygen has 2 lone pair now, but we'll try to grab there's a lot of numbers of protons, so they'll grab this one. So this will become obviously positive charge. So this now this carbonyl group become very unstable, and this is where you're gonna have ethanol comes into this carbon, okay, which is also electron very poor density carbon. So if that happens, okay, this carbon now is going to be, oxygen. There will be positive charge with the hydrogen with the one methyl group here, and this goes to there. So it will be like this one. Okay, so this will be picked up by water. So this hydrogen here, hydrogen will be gone, and pair of electron were going to be on oxygen, so it will be now neutral. Okay? And then this one will grab another proton because it's very acidic condition here. So this will grab the proton here. So this will become water with a positive charge. So it wants to leave now because it's very good leaving group now. But to do that, it had a push. So this one make a push. So there are two lone pairs still on this oxygen, they make this one to there. So then there will be a double bond, right? Plus, and they can just leave. So those pair of electron goes to water, so water can be neutral and leave, okay? In this case. And then there's just another push coming into there by just, this is a positive charge, so this is the O, this is the H here, and comes in, and this hydrogen taken by water, and this, when it does that, it goes to there. So this will be neutral again, but it's breaking this one. So that's how they can lose the hydrogen here, but attach it to in this way. So if you redraw this one, will be what? This one. So you have these two ether group lie on the same carbon, we call acetal compound. Okay. Yeah. Does it make sense? Okay. Yeah. So let's try the problem and see what we can do together. So maybe we can try, let's change this one to ethanol. Okay. We can change this one to ethanol. And then try this one. Okay. Let's do this together. So the chapter 19 is very the reaction numbers heavy. So there's a lot of reaction you need to memorize. But if you get to the some tricks you can do, it will be actually quite easier. Okay, so let's try to do this together. Okay, like this. So the trick is try to remove the carbonyl group, but remove the hydrogen here, okay? And just try to do this one twice. Okay, so the sorry. Yeah. O and O. So add this one from the oxygen part here once and twice. Okay, just do one more. Just do one more and let's finish today. This one, okay, and then try to do methanol again. Let's do this. So we switch to methanol again. Okay, so let's do this one. So just try to remove this one, carboxyl group, and add this part without hydrogen, OCH3, OCH3. Okay, that's it. So this one. All right, so that's it for today. Okay.